Hey everyone, and welcome. Today, we're going to level up your Java game. We're moving past the basic loops you learn on day one and diving into how to write code that's not just functional, but professional, efficient, and robust. If you've ever felt like your loops could be a little cleaner or faster, you're in the right place. Let's get into it. So, does this sound familiar? You write a loop. It works fine with 10 items. But then you hit it with real-world data, and suddenly it slows to a crawl. Or even worse, you're building a multi-threaded app, and out of nowhere, it crashes with some cryptic error. These are really common growing pains, but the good news is we're going to fix them today. Look, every single Java developer starts with the same fundamental building blocks, but the real art of programming is in the refinement. It's about taking something that works and making it cleaner, safer, and way more readable. So let's kick things off with the single most important improvement you can make to your everyday loops. Okay, on the left, you've got the classic C-style for loop. We've all written it a million times. But look at all the ceremony. You've got to declare and increment a counter, I, you have to check the list size on every single pass, and then you have to manually fetch the element with list.getI. Now look to the right. The for each loop is just so much cleaner. It's direct. It says exactly what it means. For each string S inside this list, do this. No counters, no off-by-one errors, just pure intent. So why is this one simple change such a big deal? Well, the benefits are huge. First off, readability goes through the roof. Your code becomes self-documenting. Second, by ditching that index variable, you completely wipe out a whole category of annoying off-by-one bugs. You know, using less than when you meant less than or equal? Yeah, gone. And the best part? There is zero performance penalty for this cleaner code, and it works on pretty much any collection you can throw at it. All right, time to level up again. We've cleaned up our basic loops, but now we're facing a much sneakier problem, the performance trap that's hiding inside nested loops. This is where simple-looking code can turn into a major bottleneck. At first glance, this code seems totally reasonable, right? We have a list of users, a list of memos, and we just need to find the matches. So for every user, we scan through the entire list of memos. But let's think about the math here. If you have 1,000 users and 1,000 memos, your code is doing 1 million comparisons. If those lists grow to 10,000 each, that's 100 million comparisons. This is what we call O of n by m complexity, and it is a complete nightmare for scalability. So how do we escape this nightmare? We stop searching and start looking things up. Instead of scanning that memo list over and over again, we're going to process it just once. We'll build a hash map where the key is the user ID we want to match on, and the value is the memo itself. Then we just loop through our user list one time, and for each user, we do a super fast, practically instant lookup in our new map. And this table just lays it all out. We've transformed our code's performance from O of n times m all the way down to O of n plus m. What that means in plain English is we went from 1 million operations down to just 2,000 in our example. The scalability goes from poor to excellent. This is how you write code that stays fast no matter how much your data grows. It's a total game changer. Okay, let's pivot to our next big challenge. We've made our code fast, but is it safe? In almost any modern application, you've got multiple things happening at once, multiple threads all trying to access the same data. And if you're not careful, your simple collection can become a ticking time bomb. Check out this classic scenario. We've got a regular old hash map to store player scores. Now imagine one thread is busy looping through the map, maybe to display a leaderboard, but at the exact same time, another thread comes in to update the map because a player just scored a point. What do you think is going to happen? This. The infamous concurrent modification exception. This is Java's way of throwing its hands up and saying, whoa, 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 you can't change the list while someone is walking through it. It's a safety mechanism. It's designed to fail fast to stop you from getting unpredictable results or corrupting your data. Now, you might think the solution involves complicated, messy synchronization code, but it's actually incredibly simple. You just swap out your hash map for its thread-safe cousin, concurrent hash map. That's it. Look at the screen. It's literally a one-word change. So what's the magic here? Concurrent hash map was built from the ground up for this exact situation. Instead of putting one giant lock on the entire map every time someone touches it, it uses a much more sophisticated system of smaller, granular locks. This means multiple threads can read and write to different parts of the map at the same time without tripping over each other. It guarantees you'll never see that crash again, and you get thread safety without killing your performance. And hey, you don't have to take my word for it. The data speaks for itself. This graph shows it all. Look at how the older synchronized maps just completely flatline as you add more threads. They become a bottleneck. But concurrent hash map, its throughput just keeps climbing. It's designed to handle the pressure. So we have tackled the big performance traps and the scary concurrency crashes. Now let's zoom in a little and look at some smarter, more subtle techniques that can really fine-tune your loops for that last bit of efficiency and power. When a for-each loop isn't quite powerful enough, you'll reach for an iterator. But it's important to know you have options. The standard iterator is your universal tool. It works on any collection, and it lets you move forward and safely remove elements. But if you know you're working with a list and you need more control, like going backwards or adding and replacing elements as you go, then the list iterator is the specialized tool you're looking for. And here is one last pro tip, and it's a big one for map iteration. On the left is what a lot of people do. They get the key set, loop through all the keys, and then for each key, they call map.getKey to fetch the value. But think about it. That get call is an extra lookup operation inside every single iteration. The much more efficient way is on the right. Use entry set. This gives you a single entry object on each pass that already has both the key and the value bundled together. No extra lookup needed. And this isn't just some tiny academic optimization. As this answer from Stack Overflow points out, using entry set is fundamentally more efficient. When you're dealing with really large maps, this simple change can make a real noticeable difference in performance. It's one of those small choices that shows you really understand how your tools work. So at the end of the day, that's what it all comes down to. Writing great code isn't about some secret, arcane knowledge. It's a collection of small, smart, deliberate choices. It's choosing the for-each loop for clarity, using a hash map to avoid a performance nightmare, and iterating with entry set to be efficient. So the next time you write a loop, just take a second to ask yourself, am I making the cleanest, safest, and most efficient choice I can? Thanks for tuning in.